All
All
right.
good.
So yeah, the test you can do in pairs, as I mentioned. I'm not sure how you're gonna pull that off, but I guess uh, you could call each other. I don't know. It's four questions or four functions to be more specific. Um, Again, you have to understand that the nature of this test is being able to manipulate linked lists. So it's not going to be something that you've done before, but obviously it will be similar to what you've done before. So if you understand the things that you've done in the program set, then obviously the test is going to be easy. But if not, then of course it's going to be a challenge. So even though you're not going to see the exact same question that you saw in a program set, there's going to be similarities because ultimately everything has to do with manipulating linked lists. There are only so many ways we can manipulate a linked list, and I've given you uh, a ton of functions to write as is for the program set. So I think people still can't hear me.
Desire, sir.
Only Desire, but the rest of you can.
Yes, I could hear you.
Sir, we could.
Okay. Yeah, I'm speaking Desire. So I guess check your volume, Desire. I don't know if you're listening to me on a cell phone or some other device. Just make sure the volume is up. All right. So that's basically it for the test on Thursday. Um, you'll be given only 1 hour and 15 minutes. See, what you have to understand is that test I normally give, I sometimes would stretch it to 2 hours, 2 hours, 15 minutes, but there's no way you're going to get that. You get the regular 1 hour, 15 minutes. Number one, because you're working with somebody else. Number two, you have access to a compiler. You have access to all previous code and examples. You understand? In a face-to-face setting, you
Sir,
have
but we're
none of
in
these things available. What's that?
So we can use the previous code.
No, you can't use the previous code.
working in pairs online more stress.
Is it more stressful, you said? Did you say it's more stressful online?
Yes, sir. I can take a lot of time to try to communicate with the person.
Well, that's why. I mean, okay. Let's put it this way.
You should do
It's
individual
up to you. It's up to
answer.
you if you want to work with somebody else. Let me put it that way. Then it's up to you if you want to work with somebody else. Um, so the question is, a number of people have asked this question. If I ask you to do a function in this test, and you remember, oh, I wrote something that could definitely help me in this particular function, you're not allowed to use it. You
But
can
the efficiency.
you can incorporate the code. You understand? But you can't. How can I say it? You can't call that function as if though it belongs to the linked list class. So you'd have to incorporate that code into the new function you're building. Does that make sense? Like you can't like import that function. You say, "Oh, I did this for a program set. I'm going to take that function and stick it inside of this, and then use it." The only functions you have available in this test are the standard linked list functions: inserted front, inserted back, remove from front, remove from back is empty and print. Anything else that you need, you'd have to actually write that code in the function I'm asking you to do. Now you might say, I have a function that I did in my program set. It's very similar to this. Well, copy that code and paste it into the function you have to build for me. All right. It's just that I don't want
Okay.
you to take your function and then call it as if though it's, although you're still to a certain degree doing that, but I prefer that we just keep it to those specific functions. Now again, beware that if two groups or more have similar code, and might go, oh, well, they're all going to look similar. No, 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 they're not going to all look similar. All right. Everybody has different approaches. I looked at some of the solutions some of you provided. Like, I think, well, it's, it's weird. Like the way everybody's mind works is just different. So if I see that, all parties will get a 0. Is that clear? This is the last thing you want. All right. And if you're dumb enough, all right, if you're dumb enough to be under this kind of stress and pressure and to still send to another group your code, risking everything, then you're really, really dumb. And I'll be more than happy to give you that 0 because you deserve it. All right. So ensure that you figure out how you're going to work with this other person. If you're going to work with somebody else, I'm not forcing you to work with somebody else. I'm just trying to help you out, right? Remember, face to face, you would have never had this opportunity, but everything has changed. So I'm just going to go with what the heck's going on in the world right now. This is the best I can do. I can't pretend that you don't have access to all sorts of things. So let's not even fool ourselves, right? I'm not stupid in the least. So I'm going to work with that. You have access to somebody else. You have access to your prior code. You have access to a compiler. You have access to everything. I'm literally giving you the list.h, listnode.h, and the driver program so you can test it as you go along to see if it actually works. So if your code sucks, you'll know right then and there. I'll just say this. If your code does not compile, comment out the functions that do not compile. All right? Just comment it out. How can I say it? Don't comment out the function. No, don't comment out the function. Keep the function as is, but comment out the body of the function. Is that clear? So that when my driver runs, it just there's no error. It just doesn't produce anything for that function. That's it. Any questions? We're good. So what is this question? Rene Allen. Oh, can't do this if true, remove at front. Yes, Rene asked if he can do something like, wait, hold on. The way you breathe could be wreaking havoc on your health. Damn it, we need to find out. The way you breathe could be wreaking havoc on your health. All right, back to this. So Rene's 100 Kobe Wagyu. All right, I need this Wagyu meat. All right, damn it, hold on. Okay, so Rene is asking if he can call function, for example, if true, remove at front. Yes, you can call any of the standard functions. All right, let me admit these minions into my class. Let them come in before I explain some more. Because then I have to repeat.
The standard function are the one from the PowerPoint, right? Sir?
Yeah. Anything that asks you to implement, that can't be used directly. You'd have to, like, if you want to use it, you have to cut and paste the code and then use it in there or whatever it is.
Sir, how much functions for?
4, yeah, 25% each. One function, if you understand what it wants, like if you understand it, can be done in like 2 minutes. One of them. The other 2, maybe like 5 or 10 minutes each. And then one of them will take a while.
Yeah, sorry. It would take 2 if we could call any other of the function we had just like call remove values. From that it would take 2 minutes.
Yes, if you could, but you're not allowed to do that, right? Because
so technically we're not gonna take 2 minutes. We're gonna take like 15 minutes for each now.
No,
Because
one of
we
them,
have that
no, one of the functions, you don't have to call anything, and it can be written like 5 lines or 4 lines. That's how simple it is. It's like a giveaway. All right.
Sir.
Yes.
So what about the count function? Because the count is already
Okay. Count is, yes, that's one of them as well. I'll allow you to use count. Count is available to you guys. All right. So
Thank you.
Okay.
that part you don't have to recreate count. Let me put it to you this way. Let me put it to you this way, guys. Since I'm giving you the list.h and listnode.h, look at your list class, right? Any function that you see I have there, you can use it. Simple as. So you don't have to like wonder, what can I call? Any function you see in that list class, you can call it. Anything else, you have to build. And you might say, oh, I built this already in program set. Well, copy and paste it and put it in there because I can't prevent you from doing that. But you're not going to create that function as a separate function in this class. You'll just have to write the code and incorporate it into the 4 functions that I want. All right. So the ones that you can call directly are the ones that I give you in the list.h. And one of them happens to be count as well. I forgot about that. So thank you for reminding me. Yes, I allowed count to be available just to make your lives easier. Yeah.
Yeah,
I-
sir.
yeah,
Another
I'm giving you a
question.
fresh.h and driver and this node. What's that, Miguel?
Yeah. Let's say there were four in a program set, right? What if they have the same body for that particular because like let's say our program set run perfectly, and then assuming it run perfectly, and then we copy that body, and the two pairs or the four of us have that particular body incorporated. Would that be count as plagiarism?
Well, the thing is, the functions that I'm asking you to build are, how can I say, no function you've built can be used in its entirety. All right. You can perhaps use parts of it. You understand what I'm saying? So the functions you've done so far, none of them can just be directly copy and paste it and boom, it's going to make this function work. You can use
Okay.
portions of it, and then you have to add additional code to make it work, or you just build it from scratch assuming you never had the function. But I can tell you none of the functions are difficult. None. Well, one of them might be a little bit time consuming, but
Like
one
the
of them is
removal.
like really easy. The other two, like, not even difficult. But the fourth one is just, it's time consuming. It requires thought. So you have to, I don't know how you're going to do it with working with somebody else, because you have to consult, or maybe you might just say split the work. You do this, and you can tell if your function works. I'm giving you the driver, all right? So you can tell if it actually does it or it doesn't do it. And again, please understand, when you give me this thing, if you realize your function is pure garbage, all right, don't delete it. Just keep the function, and the body will be commented out so that the shell is there and my driver program can still run. All right, just keep it there, and I'll run my driver so I can grade your stuff.
Sir,
Yes.
so you're going to be giving us only one file called list.h.
Now I'll give you list.h, listnode.h, and a driver program.
So how do I make my Qt open all those things at the same time and know that it's one thing? Because the last time,
Well, I'm giving you the dot profile, so
also all I have to do is say open.pro and then they'll open everything.
right, then I'll open up. You write
Because
your stuff, and then when you're done, you just send that thing back to me, or you could just send me back the list.h, and I'll just stick that into my own driver, and then I'm going to test it.
because last time I think I did try to open .pro and it just opened .pro but nothing else.
It can be Qt, unless you're not using Qt, but Qt, once you open a dot profile, it understands it opens all associated files with that pro, unless your dot profile did not actually point to the files within the project. That's possible as well. It might be searching for files and it's not there.
Oh, so
Sure,
it's supposed
sure,
to.
unless you already had the .prof file in the folder.
Well, that could be a possibility as well. All right, so I think that's enough Q&A. I need to finish stacks and queues. You're going to get another program set today. Stacks. So let us continue, minions. I'm going to do a quick recap. And please do your best to answer my questions. Do not worry. If you can't answer my questions, just try. And then by trying and you find out what the right answer is, then you're going to learn. All right. So don't listen to other people, because sometimes you think other people know the answer and they just sound smart, but they're not really any smarter than you are. All right. So don't worry about that. Just try. The whole point is try. So let me share my screen. We're going to go into this PowerPoint again. Okay. Okay, can you see my screen? You should be able to. So we're gonna go now to.
Yeah, I can see the screen.
All right. Was that Barry White? Okay, so we know what a stack is. The question is, how do you build a stack? And I told you the most obvious way would be to build it from scratch, right? And all you have to remember is a stack looks just like a linked list. Looks like one, but it has restrictions, right? A linked list has so many things you can do. You can insert the front, the back, the middle, some weird place, and you can remove, same thing. But a stack has certain rules. You violate the rules, you can't be a stack. So if you imagine a stack, it's really, just think of a stack as a vertical. The best way to be, I think I can't draw straight. Oh my God, what am I drawing? All right, so this is a stack. Just imagine a stack is a vertical linked list. All right, apparently with hips. All right, so
Question, sir.
yeah.
So then the bottommost stack object, stack, object, that's considered the bottom and the last one, right?
Yeah.
And then every previous one points to the one below it, right? Or is it from down up?
Okay, so let's see what happens, right? So if you have an empty stack, oh no, it does it straight. All right, if you have an empty stack, so the first thing you do is you create, we call it a stack node. It's like we have list node, we call it stack node. What's the difference between a stack node and list node? Nothing, just the name change, right? So then we have the data and we have the next. Now, what we do is, so remember, the stack is just like a linked list. The only difference is with a stack, you can insert at the top and you can remove from the top only. So the operations don't happen on both sides. So we have to choose, okay, so we call this the top in this case, right? So this would be the back. So we can't insert from there, we can't remove from there. So that basically means you're doing a linked list insert at front. So what would happen is, if I do an insert at front, hold on, let's add this person. If I do an insert at front, then this node, when I add, the first time I add this node, he will be first PTR. All right, and his next will be null. That's what he's going to look like. So I can imagine it in here. That's the first guy. And then first is pointing to him. All right. Now, if I add another one to the stack, again, remember it's going to do an insert at front. This is the current first guy, and he's also the last guy, right? So now when you create another one, then if he'll be the new first, then his next has to point to this guy. All right. So that means he's going to be placed on top. And then now first will refer to this node. All right. And this guy's next is still null. All right. This guy's next is still null. If I create another node, all right, he will be the new first. And he will point to this one. So he'll go on top. So he will be the new first. And his next will point to this, his one will point to that, and this will point to null. Does that answer your question or not really?
Yeah, that's perfect. So it's a stack. It's a list node, list, but without inserted back or remove from back. No,
exactly. Ultimately, a stack is just a restricted form of a linked list. That's what a stack is. It's a linked list with rules that say, hey, you can't insert at back, you can't remove from back. That's it. And then we don't call it insert the front and remove from front, because we would like to use the official terms for those operations. So instead of saying insert the front, we just say push. Instead of saying remove from front, we say pop. So we try to incorporate the actual jargon or the terms that used to describe the operation. So even though under the hood, in reality, it's just doing an insert the front or remove from front, we just call it a push, we call it a pop. So wait, is my volume that low, or is it, or some people?
So I could hear you clearly.
It is clear?
Yeah.
Yes, it's clear.
Okay, so who's saying? Louis. And then I guess you have to check your settings to see if for whatever reason your volume is low. All right. So, because I'm trying to talk like really loud. Actually, my neighbors are actually learning data structures as I teach because it's so loud. Okay. Get back to this now.
Sir, that's unfair. They're having they don't have to pay tuition.
Yeah, but then they're not going to get a degree when they're done either. So that's different. See? At least you guys get to have a piece of paper that said you spent a whole lot of money. That's such a degree is. It's just a big expensive receipt. Hopefully that receipt helps you guys to get a job. All right. So yeah.
Now
Okay.
we're relying on you to give us a job. Get us a job.
No. I can't help you guys in that regard. I wish I could. I can't. So I've just explained to you what a stack is, and I told you, well, you can build this from scratch. And when I say build it from scratch, I just want you to imagine right now, right? Just shut your eyes. So let's see what a stack would look like. Imagine a linked list, the list.h class, right? Imagine that. Where you change the name class list to class stack. And then you removed all the code for inserted back. You removed all the code for remove from back. All right? And then you rename the function inserted front to push. And you rename the function remove from front to pop. What do you have? You have a stack. You have a stack class. So that's one way of doing it, writing it from scratch. All right? And so the code would look identical to the list class, except you would have removed two functions from it. And the ones you kept, you would have renamed them to the appropriate functions, push and pop, or names push and pop. That's one way. I'm not going to stop you from creating a stack that way. But there's another way, and I mentioned this, which is using inheritance. And inheritance is different in that it allows a programmer to not waste time, all right? Because you can reuse an existing class. If you know that there's a class that has a lot of the functionality that you need already, why rebuild that thing from scratch? All right? Just like car manufacturers. Car manufacturers, every year, what they normally do is they just take the same engine that they have, and they keep on just like slightly improving it. All right? Unless there's a significant change in engineering strategy, that same engine just gets reused year after year with slight tweaks. All right? And that's what you're doing. If you want to build, for example, a stack class, and you go, wait a minute, this stack class looks almost identical to the list class. Either you build it from scratch, or you say, I'm going to build a stack class from the list class. That whole approach of from another class, that's called inheritance. And I explained to you what inheritance is. So now I'm going to ask you questions about inheritance. And even though you might not verbally say your answer, or you might not put it in chat, I really want you to think about your answer so that if it's wrong, you already tried and you can hear what the actual answer is. You can't just wait for other people to give the answer. Try. And if you're shy to say your answer, just don't worry, but you have to think about the answer in your head. So here go the questions. Let's begin. When you inherit from a class, what exactly do you receive from that class that you inherit from? What do you receive? I'm going to check the chat. People are typing away. You receive everything.
Template.
You receive everything. What does everything mean? Who'd like to tell me what they mean by everything?
All the data members and its implementations.
So all data members and all member functions, correct? What about things that were labeled as private? Do I get those?
Yes.
Depends? Or yes?
Yes.
There's a difference. Which one? Yes or depends?
It's yes.
Yes. 100%. You get everything. That's the one thing. Just remember that. When you do inheritance, you get everything. Okay. That's the first thing. Fine. Now, when you do inheritance, you have to tell the compiler where to put the stuff that you got. And I gave you this analogy, right? I said, pretend that some, like you're very wealthy. Okay, let's go back to Azer, right? Azer has a sugar mama, right? And Azer's sugar mama died. We don't know how, but she left Azer with everything that she had. All right, everything that she had. So this big truck has now come in front of Azer's house, and truck driver has jumped out and is asking Azer, all right, where do you want me to put the stuff? All right, now this truck contains everything from his sugar mama. Jewelry, the toilet, the vehicle, everything you can imagine is in this truck. Now, Azer has 3 options, right? Azer can say, put everything in front of my yard, right? Not on the street, but in front of my yard. Or put everything in my yard. Or put everything in my house. Which one of the access specifiers would mean put everything in front of my house, in front of the yard, outside of the house?
Public.
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 Which one would be in the yard?
Protected.
Protected. And then in the house would be obviously private. So now, let's say you chose public. All right? You chose public. Now, what will the truck driver do? Will the truck driver actually dump everything from the truck in front of your yard because you said put it in the front public? Will the
No.
truck driver do that?
No.
No. And this is something you have to understand. I gave you a very specific rule, right? This is a rule you have to, this is one of those things you have to get a tattoo with, all right? So the rule is, you can never go from restricted to less restricted. So that means if something was private in a class and you inherit it, you can't all of a sudden make that thing become protected, or you can't make that thing become public. All right? You can only go from restricted to equal restriction or greater restriction. You can never go backwards. Is that clear? Because if that was allowed, if I wanted to violate the privacy of classes, I would just start inheriting from all sorts of classes. And that means I get everything. I have access to everything. And then I would screw up the whole concept of classes, because classes have been designed to ensure that information is hidden from the outside world. So if that feature could be violated simply by saying, oh, okay, this is private, but you know what? I know how to go around this. I'm just going to inherit from it and do a public inheritance. That will violate everything. So just remember the rule, all right? So when you go to your little tattoo friend, you're going to tell the person to write what? What's going to be your tattoo, all right? And you're going to put it on your forehead. Why? Because most of you don't have friends. You're not getting the right kind of attention. This will garner you a lot of attention. So what are you going to put on your forehead, guys? What is it? What's the phrase? Come on. What's the phrase? Can never be free. Ouch. Nobody wants to tell me what the tattoo is going to be? You bunch of little minions. All right? The tattoo is going to be, you can never go from restricted to less restricted. You can only go from restricted to equal or greater restriction. In other words, if something was private, you can't go to protected or public. If something was protected, you can't go to public. If something was public, well, he's public. But if something was public, you can make him become protected. If something was protected, you can make him become private. So the highest form of restriction is private. Protected sounds like, man, protected. You have machine guns surrounding you. No, the highest form of restriction is private, followed by protected, followed by public. All right? So just remember one more time. All right? You can only go from restricted to equal restriction or greater restriction. All right? So having said that, even though Azer came out of his yard, right? And told this truck driver, hey, put everything in the front of my yard, the truck driver is only allowed to put what in the front of the yard?
Public.
Only the things that were already public can go in the front of the yard. The things that were already protected will continue to be protected. The things were private will continue to be private. Okay, let's pretend something else. Let's pretend now Azer said, oh, no, I cherish everything from my sugar mama. I don't want anybody to like have access to the stuff. So Azer told the truck driver, listen, I want you to put all of this stuff in my house. All right? So now all of a sudden, what's going to happen? That means private. You said private inheritance. What's going to happen now? This thing will end in 1 minute.
Everything goes into the house instead of the
Everything will be in the
yard.
house. So even your public functions from the list class, right? Like insert at front, insert at back, remove from front, remove from back, is empty, print. All of those things that were originally public in the list class, they are now private within your class. Or in other words, they are now inside of Azer's house. So nobody knows that Azer actually had a sugar mama because nobody can see it. The only person who knows it is Azer. You understand? Only Azer knows this because everything he got, he said, you know what? I'm going to hide this from the world. I'm going to put it in the private section of my class. Does that make sense? So where do you specify where to put the stuff that you get? And you specify that right here. When you create your class, for example, I say class stack, the colon, just a single colon, not double colon. It's not the scope resolution operator. This is just the single colon. This means inheritance. And what you put after this is the type of inheritance. So one of three things can be played. Wow, that was pretty fast. Everybody came back on. Or did you guys have to like click the link, or when I restarted, it just kept you guys there?
Kick we all out too, sir, so we have to join back.
Yeah.
Oh, okay. All right. Because that was pretty fast, you guys. All right. Okay. All right. Back to this. Now we have 45 people. Yeah, we should be 47. We like learning, sir. No, Azer, I know you guys don't like learning. You just like learning about, you just want everybody to hear about your sugar mama. That's it. That's it. We know it, dude. We know it. All right. Okay. So let me share my screen again. I don't lie, Azer. I only lie after 6 p.m. Before 6 p.m., it's all truth that comes out of my mouth. So share screen. There it is. All right. Okay. So what was that about this? All right, I guess you should be able to see this now. So here, how do you specify a class inherits from another class? You put the name of the class, you follow by a colon, and then you put what type of inheritance. You have to choose what type of inheritance, all right? And again, you only have three options: public, private, protected. All right? So in this case, the authors of the book chose to make this class do private inheritance. What does that mean? It means, well, first of all, we specify the type of inheritance, and then you have to specify who are you inheriting from. In this case, I'm saying class stack that I'm building should inherit from class list. Now, look, the first thing the compiler is going to ask you is who the hell is class list that you talk about, right? It's just like when Azer brags and says, this is my sugar mama. People are like, what sugar mama, right? Show me proof, right? And then Azer will have to take out the pictures and blah, blah, blah. Like nobody wants to see it, but anyway, Azer has to show proof. So the same thing with this class, when you're building this class stack, all right? The compiler needs to know who the hell is class list that you're inheriting from. And the proof is line 6. Line 6 says include list.h. This is the code. This is the file that contains the code for the list class from which you are inheriting. All right. So that's why we have to have line 6. You can't just say, I inherit from class list. The compiler wants to know who the hell is class list. Show me the code. And that's what this is. All right. It's like from Jerry Maguire. Instead of saying, show me the money, we're saying, show me the class. And that's what we're doing in line 6. That is such a real weird analogy. Okay.
Sir, what about stack type in line 9?
Stack type in line 9. Oh, okay. I'm going to explain it right now. So yeah, I'm going to explain. So let's cover the basics and then I'll cover that. So now we know how to inherit from a class. You just put the name of the class, put a colon, specify what type of inheritance, and tell the compiler which class you want to inherit from. And then above your class, include the file that contains the class declaration that you're inheriting from. And that's it. That's it. That's all you need to do. So the reality is, I could have done this. You could have done it as simple as this. Let me just show you. All right. I could have done this. I could have said, hold on. Oops. Pretend that's a double colon. All right. And then I have class stack private list. All right. This is not a drunk 3. All right. That's a curly brace. It's like, there. Freak. Anyway, this is it. This is it. You can have a class as simple as this. Nothing inside. Nothing inside. And this is a valid class. All right. This says I'm a class called stack. I inherit from class list and I do private inheritance. You could leave the inside of this completely empty. All right. You can leave this completely empty and this would compile and run. All right. That's perfectly valid. Now let's say I did that. Let's say I did this. Okay. Pretend there's nothing in the body of this class. I just built this class using inheritance and I put nothing in there. And let's say I'm inside of main. I'm inside of main. What can I do? Well, I can do this. I can build stack object. And just pretend we had all of this. I didn't want to write all of this, but we had template, blah, 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 blah. And I go like this. And I say, I want to build a stack of type int. I want to call it S. All right. And then what can I do with S now? I'm inside of main. This is main. This is main. What can I do with this dude? What can I do? Anybody?
Insert at front.
Insert at front. Let me see. Who said that? I'm trying to bring up the people. Who said insert at front? Me. Okay.
Jadon.
So Jadon. All right. Jadon says I can do this. Let's see if Jadon is right. S dot insert at front. All right. And let's see A, and I did this. Int A is the same.
Sir, wouldn't it be push?
Can I do this? Can I do this?
I don't think so, sir. I think you'd need to call a function push.
No,
No,
this
no,
is valid.
No,
No,
We're doing a
just-
different
guys,
class.
remember-
Private.
This code, this is not there. This code is not there. The only thing you have is this class stack, private list, and open curly brace, close curly brace, semicolon, nothing in the middle. This one has stuff in the middle. The one example on the slides has stuff in the middle. This one that I just built has nothing. And this is a legitimate class. with this example that I have, no, not the one that the authors of the book gave you, this one, can I do this? That's what my question is. Can I do this?
Yes.
Okay, so Jacob says yes, Jaden says yes. Anybody else? Like say the conviction.
Yes.
I'm gonna call from no caller ID. I don't know who the hell that is. I hate when I get called like that. What does that mean if it's no caller ID? It means
It's a private number or it's a business number, something like that.
because normally private says private. Anyway. So
Not with iPhone, sir.
not that iPhone. Okay. Anyway. So back to this, right? Can I do this line? No. This is illegal. This line, S dot insert the front is illegal. Why? Why is it illegal? Somebody give me a really good answer why that's illegal.
Because you have the list, you have the let's say you have the use of the private list functions and data members as private, so you can't use the enemy.
So exactly. So this is what I want you to imagine, right? You left this empty, right? You left this empty. But in reality, so this is the real question. Is class stack empty?
No.
No. You didn't put any functions directly. When I say directly, I mean, wait, that's a lie. You did. Once you did this little part right there, you actually dumped a whole lot of stuff inside of class stack. You didn't put anything extra in here, but a whole bunch of stuff came into class stack. So class stack is definitely not empty. All right. The issue is because you said dump everything you got from class list into the private section of class stack. So just imagine there's a private section of class stack and everything inserted front, inserted back, remove from front, remove from back, print is empty. First PTR, last PTR, everything, get new, everything is now in a private section of class stack. So if somebody inside of main says, well, I have a stack object, let me call insert the front. That's illegal because this guy has this function. Yes, we're not saying he doesn't have insert the front. This function exists. Yes, this function 100% exists. The problem is this is currently within the private section of the stack class. So you're not allowed to call this directly. Does that make sense? You're not allowed to call it. So this is illegal. In fact, you can't call anything. So if I left this like this, what can I do with the stack class? Not a damn thing. You have a useless class. You have built a useless class. You just built a class called stack. Yeah, beautiful. It has a name stack. Who cares? But incapable of doing anything. Because once you build a stack object, once you build it, right? Useless. You can't call any function. So you probably think, oh, okay. It's useless. I know how to fix this. What I'm going to do instead is I'm going to change this to public, problem solved. What did you just do? I just changed one word from private to public. What have you just done? What's the effect
Now
of
you can use the public. Now you can use the public member functions from list in a stack.
Okay, but go a little bit more backwards. Tell me, like, give me more details. Like, what did that changing of that one word do in terms of, did you get the same things that you got when you did private? Yes, that doesn't change, right? You still get the same things, everything. That one word caused what to happen?
You can use it in the main.
No, but what is the effect of changing this to public? What is the effect? That's what I want to know.
It sets other functions in the list class to public in the stack class.
You're saying take everything from the list class. Public members, protected members, private members, everything. Take all of those things and put it in the public section of the stack class. Right?
No.
Sir, but if it was private on the other one, it wouldn't be public
No,
here
no, no, no,
because
no, 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 no. True, that is true. So I'm gonna ask you what is the effect of it. I'm not saying it actually happened, right? I'm saying what is the effect. So if I have this now, let's go back. I did this, and I did this, and I did public, right? Right, and I did all right. Inherit from list, blah blah blah. Star. All right, and then hold on, and then again, let's pretend I did nothing else. Nothing else. I left this empty. You see how this has stuff? Forget this. None of this is inside. I just left it like this. And I'm back inside of min. Back inside of min. All right. And I did stack int s. All right. What can I, and I didn't have this. Let's just try it. What can I do with Mr. S? What can I do? That's a real
Remove from-
question. What can I
Remove
do?
from back, insert at back.
You can use all the member functions that are in the public.
Yeah, you could use the public member functions only.
All right. So somebody looking at the stack class can go, oh, a stack should only insert the front and remove from front. But guess what? Not only can you do that, but you can call remove from back, insert at back, print is empty. You can call anything that was in the list class that was public. Why is that the case? How come now I can call any function from the list class that was public? And the reason is okay, so this is what you have to understand. This thing of this has only a recommendation. Just like when Azer went to the truck driver, right? The truck driver listened to what Azer said, and the truck driver thought carefully and realized Azer is a little bit nutty. I can't listen to what Azer is saying. I will try to listen to what Azer says to a certain degree, but some of the things he says does not make sense. All right? Maybe Azer did not have enough sleep. I can't take this woman's jewelry and put it in the front lawn. All right? That doesn't make sense. Okay? I can't do that. I can put her vehicle in the front of the yard because that makes sense. You don't put vehicles inside of the house. But I can't put that woman's jewelry in the front of the lawn. I can't listen to Azer. Azer is a little bit nutty. That's what's happening here. This is a recommendation. The compiler will try to do its best to listen to you, but it cannot exactly do it if what you're saying is wrong. So when you said public, what your recommendation is to take everything from list, private, public, protected, and put it in the public section of this class. The problem is, the rule says you can only go from restricted to greater or equal, to equal or greater restriction. You cannot go to less restricted. So something that was private inside of list will not all of a sudden become public inside of this class. That's going to violate the rules of encapsulation. So just because you said public, compiler says, screw you, this thing was private here, he's going to continue being private. Does that make sense? So insert at front, insert at back, remove from front, remove from back, is empty, and print were originally public here, so they keep on being public inside of your class. They keep on being public because of what you did there. But first PTR and last PTR, those two guys, and get new node that were originally private will continue to remain private within class stack. Even though you said public, they will continue. First PTR, last PTR, and get new node were originally private inside of this class. They will continue to be private regardless of the fact that you said make them public. The danger now is you have caused this effect. All right, so now I can do this. And when I do this, the fact that I can do this, are you actually a stack? You are a stack by name, but not actually a stack. So this is, you can do this, but you are an imposter. You have the name stack, but you're doing something. You're doing things that a stack cannot do. Does that make sense? What I'm telling you right now? You're doing things that a stack should not be able to do.
Yes, sir.
Good. So what is the best choice? Should I keep it as public or should I make it private?
Private.
Private. Because if I did public, you end up with nonsense like this. But if I make it private, oops. Oh, crap. Crap. No, man. Ah, man. Sorry. So if I make it private, I go back to the original problem, right? I go back to the original problem if I make it private. Now, nobody can do this. Nobody can do this. Insert at blah, blah, blah. None of those functions can be called. So you fixed one problem, but you created another one. So nobody can call insert in front. Nobody can call insert at back. Remove from front, remove from back is empty print. Nobody. Because you did private. But I want people to be able to use those functions, but I can't make them call those functions directly. So what do? So I come inside of my stack class and I create a bunch of public functions. The first public function I create is called push. And I tell the compiler to create a parameter that looks like this. And what do I do? Why do I do this? Okay, so this is the important question. Why do I tell the compiler to create a bunch of public functions? Well, because since you did private inheritance, none of those functions are available to the outside world. So it's useless. Their existence is currently useless. I would like to use those functions. I just don't want people to call them directly. So instead I create public functions and I name it push, for example. And what do? In the body of my public function, I tell this guy, which is the function I inherited, right? I tell this guy to call insert at front. And remember, insert at front wants the value. So the same value that insert at front wants, I have to somehow get it to him. So I create a parameter that looks just like the one from insert at front. So now what can the outside world do? So if I'm inside of main, I can do this. I can create my stack object. Then I can say s.push, right? And I can push A. What's going to happen? You made push public. So A will get passed into this part. So now data is now A. And then under the hood, where nobody knows, right? Nobody knows how you did this. You call the function you inherited, which is insert at front, and you pass in data to insert at front. And insert at front, you know how that works. We'll then create a new node, pass in the data, which is 9, set that thing to null, and attach that to your list or your stack. Does that make sense? Or are you confused? Let me check the chat because chat looks very busy. So we make everything private so that the matter. Yes, you make it private so nobody has access to the things you got, right? And then you control how those things you received can be used. So I create public functions that the outside world can call, but internally, I make my public functions call those private functions. So nobody knows how you're making it work. You understand? Nobody knows how the work is actually happening or being dealt with. They only know, oh, this guy's a function called push. How push works? They don't know that you're calling a function you inherited. Like, yes, like a secret service. Nobody knows how it works. They just know that you have a public function called push, and push wants something. Okay? You've pushed the thing he wants, and under the hood, push calls insert at front. Same thing with pop. You create a function called pop. Now remember, pop is actually doing remove from front. So when we create this function called pop, under the hood, the function really does the work for us is called remove from front. As you recall, remove from front has a parameter. Now, nobody really ever asked me why function remove and function remove from front or function remove from back had parameters. This is the reason. So let me explain that to you right now, because I think a lot of people never really understood. Let me show you. What? So why does, you can see my screen, right? Why does remove from front and remove from back have parameters? We know why the insert functions have parameters, because the thing you pass in will be inserted. But why would a remove want something from you? Isn't this guy's job to remove a node? Why are you asking me for something? This is the reason. Notice it's a reference parameter. The way this thing works is the remove function allows you the opportunity to get the node that he removes, to not just remove it from the list, right? Yes, he's going to remove it from the list. Once he's done, that node is no longer part of the list. But what if you would like the data portion of that node? What if you wanted that? So that's what this function allows you to do. It allows you to pass in int, for example, but because you're passing it by reference, then when the object is destroyed, let me show you. So what happens here is you pass in some dummy value, right? Doesn't matter what it is. Then this guy goes to the node that he has to remove, and then he takes the data of the node he's about to remove. He takes the data of the node he's about to remove, and he assigns it to value. Who is value? Value is the parameter you supplied. It's a reference parameter, so that means whatever you pass in, whatever changes you make to this guy will be felt outside. And then you delete the node, so the node is now deleted, and when this function ends, value is available outside of the function. So just in case you wanted to have the data portion of the node you just removed, you have that available to you. So that's why the remove from front and remove from back have parameters. All right? So coming back to this, since you're going to call remove from front, and remove from front wanted something, that means pop needs to also have a parameter. And we're going to pass data to remove from front. Now I want you to notice something. When we called insert at front, we just called it. But when we called pop, we put the word return in front of it. Why? This is very important. How come we did not put the word return when we called insert at front, but we did return and then we called remove from front? Why is that?
Because it's bool. It's bool pop.
Right. Insert at front and insert at back. Did they return anything? Those functions from the list class. Those functions didn't return anything, right? But remove from front and remove from back return a bool to signify whether or not the removal was successful. So pop has to also return the same thing. So what has to happen is that you're saying return the result of calling remove from front. So whatever remove from front returns, if he returns true or false, we're going to return that, and then in turn, pop is going to return that. Does that make sense? I don't know if that makes sense to you guys. Should.
Sir?
Yes.
Yeah, it's making sense now.
And somebody had a question? I heard something. Does it make sense? Okay. And similarly, come on, dude. And then we do the same thing. Is stack empty? We create a public function called is stack empty. And then remember, who does the actual work? It's the isEmpty function from the list class. But isEmpty returns true or false. So in order for isStackEmpty to return true or false, we have to return the result of isEmpty. All right. Now when then we created a public function called print stack. But print stack calls who to do the actual printing? He calls the print function from the list class. But the print function from the list class does not return anything. That's why we just call it. We don't put the word return in front of it because he doesn't return anything. And so he also has a return type of void. And as simple as it is, you've just built yourself a stack class. Okay? We could have also taken a different approach. The third approach. So the first approach of building a stack was to build it using building it from scratch. We talked about that. This is just that you're going to have to write all the code that you would have found in this class. Insert the front and insert and remove from front. That was the first way. The second way was inheritance, assuming you have a class that has most of the functions you need. And the third way is using what is called composition. All right, how does composition work? Composition is based on the idea of composed of. If I tell you something is composed of something, what am I really saying to you? If something is composed of something, in it. Right? It's made up of certain things, right? It's made up of something. So remember, this is the third approach for building a class using composition. So what can we do? Well, we can create a stack class, as you're seeing right here. We're creating a stack class. And notice there's no inheritance happening. And the way you can tell is because there's no colon, there's nothing happening here. It's just, it looks from our perspective, it looks like a regular stack class. All right? But I want you to notice we are not writing all of those codes, right? You know this? We still have function push, we have function pop, right? But who's actually doing the work? What we do instead is, what we're doing is instead we create a private data member in class stack of type list. In other words, this is what we did. We created a stack class. We created a stack class, yes, but we created a private, it's going to run out soon. We created a private list object or list data member within our stack class. So let me show you what we actually did. So we said, all right, you know what? I'm going to build a stack class, but instead of doing inheritance, I'm going to do composition. So you did this. You said, all right, class stack. All right. And then you said public push. All right. And then all right. Then you called your list objects, insert at front, and you passed in val. All right. So now this stack class that you just built has a private stack type object called list object. What does that mean? Again, remember, you are, whenever you do inheritance or composition, okay, so just give me a quick answer. Why would I want to do inheritance or composition? What's the simplest answer?
Don't rewrite, reuse.
To not build it from scratch.
Stop building from scratch, reuse stuff that has already been tested and proven, right? So I've decided I don't want to build a stack class from scratch. I can do it, but I don't have time for that. So I'm just going to use composition. Now, composition says there's no inheritance happening. Instead, you're going to create a private data member of the class that you find useful. So which class do I find useful? I find the list class to be useful, but I make him private. So if he's private, that means if I were in main, so if this is main, right, and I create a stack object, S, can I do this? Can I say S dot can I do this? Can I do S dot list object dot insert the front? Can I access this guy from my stack object that I just created here?
Yeah.
Yes?
Where does list object come from?
Here, this is this guy. It's in the stack class. I made him private. Can we do this inside of main? Within main, can I do this?
No, sir.
Yeah, push.
No.
You do push.
This is private. This is private. Remember, this is private. What is he? He's a list object. Yes, he's a list object, but he's private. You made him private. So you can't use a stack object to refer to this object. He's private. So that means there's no way for the outside world to call insert the front directly, or insert the back, or remove from front, or remove from back, or is enter, or print. You can't call any of those functions because the outside world does not know about this guy's existence. You understand? Who knows about this guy? Only stack knows. So what does stack have to do? Stack will create a public function called push, and under the hood, who does push call? Push tells this dude, hey, list object, call your insert at front function, and then he passes in this value. Does that make sense? That's what he does there. So what he does is he uses his list object, right, to do all the dirty work for him. That's what he does in that case. Does that make sense?
Yeah.
Yes.
This is
So-
very important. You understand the difference. One
So
of them is inheritance. One is inheritance that says all the functions are inside of stack. They're part of stack. They are part of stack. Composition, they're not a part of stack. The only thing that stack has is an object of the class that he finds useful. But we make it private so nobody can call it directly, and then we create public functions, and we make the public functions do the dirty work by make the public functions call the private object to do the dirty work for us. Does that make sense? You guys understand or you're confused? You have to tell me. I'm muted? Oh.
No.
Does it make sense or you guys are confused? Okay, look. I want to build a
So-
stack class, right? I don't want to build it from scratch. And for example, somebody said you're not allowed to use inheritance. I go, okay, I can't use inheritance, and I sure as heck don't want to build it from scratch. Is there another way? Well, I know that the list class can do the things that I want. So what do? I create a private list object. All right, so I create a list object, and I call it stack list. Call it whatever the heck you want. Make it private. Then you create public functions. Push, pop, they're public. Push, pop, stack empty, print stack. That's what you do. All right? That's what you do. And from the perspective of the outside world does not know about the existence of this guy. Nobody knows about this. All right? Nobody knows about this. All they know is that, hey, you have a function called push. You have a function called pop. You have a function called isStackEmpty, and you have a function called printStack. They don't know how those functions work. They just know that they can call it. They don't know how it works. You know that internally, you have this little guy that does all the hard work for you. So what's going to happen is, when somebody calls your public push function, and of course you have to create this parameter, right? They're going to pass in something. That's something that this push receives. He will then pass it on to his private list object and say, hey, list object, call your insert at front and pass in this thing. When somebody calls pop, then we're going to tell the same list object, hey, call your remove from front. When somebody calls is stack empty, we're telling the object, hey, call your is empty. When somebody calls print stack, we're telling the list object, call your print. And this way, once again, we are preventing the world from calling functions such as insert at back, remove from back, things that you don't want people to call. We're preventing that from happening because we're making this guy private. He does the work for us. We make it private, and then we just create public functions that do the work for us. Does that make sense to you guys?
Yes.
Bueno.
Yeah.
All right.
Bueno.
So having said that, then what I will need from you, you're going to have to do is, you can submit this in pairs, right? So you can submit this in pairs. But for today's what? Thursday, just send me one file, all right? Which is your implementation of a queue class, of a queue built using composition. So you have to build a queue class using composition. Now let me just quickly, we have 1 minute. What functions does a queue have? If I wanted to take the functions from a list that would work with a queue, which functions from the list could I use in a queue? Well,
remove
represents a
from
waiting line. It can be
Insert
insert
at
at
back, remove from
back, remove from front. So the same principle, if I told you to build a queue from using composition, you do the same thing like you did here, like you're seeing here, except instead of calling the function push, you'd call it enqueue. Instead of calling it pop, you'd call it dequeue. And then you tell your list object to call insert at back, and you'd call your dequeue, you'd call it remove from front. All right, that's it. I just want you to build that so that I can see that you did it. All right, it's going to be considered as a quiz grid. All right, so do it as pairs. So do it as pairs. Send it to me, just so that you have something that works. All right. So if I check to see if it